This week we're going to have the second half of the Chapter 1 test, and those topics include distribution, simplifying by combining like terms. We looked at various types of equations on how to solve them, and then we talked toward the end about relations and functions. So let's do a review since our test is this week. Let's start by simplifying expressions that require us to do a distribution. When we're doing a distribution, the key to this is remembering to multiply by both terms within the parentheses. That's 4 times 7x, which is 28x, and 4 times the 5 minus 20. Again, outside term multiply once, 24x, multiply twice. This time there's a negative. When I have multiplied by the negative, it will change the signs. That's a negative 20x squared plus 35x. Now again, none of these can be simplified any further because they do not contain like terms. In the next group, I'm going to simplify completely, which probably requires us to do some combining like terms as well. I've got a 9x. Now I'm going to multiply that 4 once. 4 times x. And now I see I do have like terms. Same variable raised to the same power. We can add those coefficients. And there's our answer. Again, we're simplifying. So if there are parentheses, we will distribute first. 12x plus 30 minus 10. Well, constants are also like terms. I've got a 12x plus 20. Last one of this type. I'm going to start by distributing. So I've got 4 times 2x is 8x. And then the 4 times 3 is minus 12. And then I have this minus x. Now, remembering the properties, I could take the 8x and change places or commute these two last terms so that I have my like terms together, and I'll have a 7x minus 12. And that's all we did with distribution and combining like terms, both of which were important when we were solving equations. But we started off with one-step equations first. One inverse operation. I see multiply, it tells me I should divide. I'm going to get x is equal to negative 5. And again, if I do a check, negative 5 times negative 4 will give me a positive 20. I have 5 plus x, so I need to use my properties of equality and subtract 5 on both sides. That will cancel us out on the left. I'm left with x is equal to 4. To do a check, 5 plus 4 equals 9. It checks. Occasionally we'll see our variable on the right. We're still isolating it. We're still looking at an inverse operation. Here I have 6 is equal to x. I like to do the interchange and always put my variable first. And there we have our one steps. We're going to add, subtract, multiply, or divide. An example of a divide would be if I had x divided by 2 equals 4. I would multiply both sides by 2. And I get x is equal to 8. Let's move on to the next part of solving equations, which are the two-step and the multi-step. In our two-step, we might have two inverse operations, or we may even encounter a combined like terms as well. Let's see a few of those. In this first one, it appears I have two inverse operations. I'll start by subtracting 2. That leaves me with 4x is equal to 28. Last part, divide by 4, give the answer away. X is equal to 7. Two inverse operations. Let's start by adding 1 to both sides. I have x divided by 5 equals 5. The inverse of division is multiplication. Let's multiply both sides by 5, and we get a solution of x is equal to 25. Let's check it if we're not sure. 25 divided by 5 is 5. 5 minus 1 is 4. The third problem has variables on both sides, so the very first step, if there's nothing to simplify, is to collect them to one side. I'm now left with 3x plus 3 is equal to 18. Now I have two inverse operations. Let's subtract 3 on both sides. That leaves me with 3x is equal to 15. And lastly, we'll divide. X is equal to 5. We have two more here to do. On this first one, I see some like terms to combine. So again, before we move anything, let's simplify. So I have 6x plus 6 on the left, a distribution on the right, 6x plus 6. Variables on both sides, let's collect them to one side. And what happens here? The variables cancel out. 6 is equal to 6, which is an identity. And in an identity, we have infinite solutions, or x is equal to all real numbers. So again, let's not forget to write that. X is equal to all real numbers. So when we have variables on both sides, we just had an example where we still have one solution, and here we have infinite solutions. Looking at this final question here, I've got 9x minus 1x is 8x plus 4. On the opposite side, I have to combine like terms. Constants are like terms. 6 minus 4 is 2. When I subtract that 6x on both sides, 8x on both sides, they cancel out. I have 4 equals 2. Last time I checked, that's a false statement, so there is no solution. So again, I'm just quickly going over all the types. I won't start a new lesson today. Today is just about the review. And one last topic that came up was representing data as mapping and tables in ordered pairs and on graphs. I'm asking you here to represent each of the following set of data in a mapping situation. Remember that this is my x and y ordered pairs, and that my x terms are my domain or my input. Can't say these words enough. My domain or my input. And then the y terms are my range or my output. Knowing that terminology, very important. Okay, so let's take the x terms and put them in the first part of the mapping. 3, 4, and 5. We only have to write each number once. So 3, 4, and 5 are in my first. And then I have my 5, 7, and 9 in my second. Let's now pair them off. 3 to 5, 4 to 7, 5 to 9, and 4 to 9. The next part of this question is whether this represents a function or not. Well, if a function says that every input can only have one output, and we look at this 4 repeating, but it has different outputs, this one is not a function. And let's do it again. This time, instead of giving you ordered pairs, I gave you a table of values. We will list all the x values, which are my domain or my input, and let's list all of our y values, which are the range or the output. 1 pairs with 6, 2 pairs with 8, 3 pairs with 8, and 4 pairs with 6. Your goal is to look at your input values. If every input only has one output, you have a function. And I think you're getting pretty good with recognizing when it is and when it's not. The final topic on this test is evaluating functions in function notation. We take out y and put in f of x. I give you a value and you substitute it in. You simplify by doing the math. And this tells me that when I input 5, my output is 30. Let's just do one final problem for today. Let's input or substitute in 6. So I've got 6 squared plus 4 times 6. That'll give me 36 plus 24. When I combine those, I get 60. So when I input value of 6, my output is 60. And that's the topics on this test. Tomorrow, we start a new lesson. But if there's anything you feel you need to review, bring those questions to class.